Hi, my name is Albi from Skylab. Skylab is a German tech company, and we're specialized in data analytics, area data analytics for the forestry industry worldwide, which means we develop and apply algorithms for tree and seedling counting, for total timber stock and carbon stock modeling, for continuous harvest monitoring, or for monitoring and quantifying forest change. So, for example, vitality, forest health, loss of canopy, dead trees, and so forth. Today I'd like to focus on our seedling counter, seedling and tree counting, using deep learning algorithms and AI to maximize the value from this data for the forest manager. I'd like to do this in the form of a little story. It's the short story in the life of an algorithm. Our algorithm was born in 2019 and it set out to become really good at counting and recognizing seedlings. Let's call it little c because it just likes to count. And we'll look at this life of our algorithm from early childhood through rampant and somewhat unreliable adolescence through to early adulthood, where it starts to take responsibility for its actions. So we'd like to answer the main question in seedling management: how many seedlings have survived, and how many are failing, and where are they failing, and why do they fail? Of course, counting all those seedlings in this example, 300 hectares, is not a viable option. So the way you do it today, of course, is you take out spot samples, you count the seedlings in those samples, you repeat that exercise until you have enough samples that are more or less representative of the total area, and that gives you a pretty good idea of the survival situation in the entire area. But it's still kind of patchy. You have a good average and you have a fairly good idea of poor and better performing sites, but it's still only maybe 1, 2, or 3% of the total area that was analyzed. Well, we set out to change this. We want to enable you to get the full picture. So we and our algorithm, little c, think that counting all those seedlings isn't such a crazy idea after all. So we counted all the seedlings in this example, and we counted 314,585 seedlings. Now I think it's a good point to look at two real-life examples of this. The first one we're going to look at is from Australian bluegum, ABP, who, after about a year of intense testing with us, took a leap of faith in late 2019 and asked us to analyze their entire 2019 seedling generation in the Green Triangle, which is roughly 4,000 hectares, and we did that in March and February 2020. So this is the kind of results that we provided to ABP. So we come up with density maps where every 20 by 20 meter grid cell represents the number of seedlings survived per hectare to show the variation across the entire stand. So you can see really poor performing areas in the middle and very well performing areas on either side. Of course, that gives you a direct idea of where to take action and to take a closer look to analyze what's going on and what went wrong. To add to the information, we also provide weed maps that basically analyze the density of weeds across the entire field, and also the vitality map showing the relative vitality of the seedlings across the entire field. So this additional information should enable you to understand what's going on in the entire stand. Of course, all these maps can be represented as grid cell maps as well. Now, you may ask yourself, but how accurate is it? Well, of course, ABP wanted to know that as well. And they did a fairly detailed analysis of the results. They laid out 84 sample plots across the entire area, being more or less representative of their stands. Mind you, 84 plots are about equal to 0.1% of the entire area analyzed by us. And there was some time difference between our analysis and the ground sampling, but nevertheless, the general story remains that In some areas there was an overestimation. So, for example, in areas with a lot of weeds and large seedlings, some of the weed was recognized falsely as seedlings, so an overestimation of seedling survival. And in other areas where the weeds were fairly large in comparison to smaller seedlings, there was an underestimation of the seedling survival. On the whole, our algorithm somewhat underestimated the seedling survival, and ABP's conclusion was that the accuracy needs to be improved for future work. So our conclusion was we need to get better. But did ABP think the grid maps were not useful? Well, quite to the contrary. They felt that the grid maps provided great value, especially in identifying failures, areas of high weed density and of poor vitality. So the georeferenced maps enabled them to take targeted action where it was needed. In fact, they gave the maps to contractors who were then able to go directly into the field and do the work as directed by the maps. But there was also more longer-term interesting lesson to be learned, how different management practices of harvesting, of treating harvesting residues, of ground preparation influence the survival of future seedlings. So by understanding this relationship and taking action, you can change those management practices and improve survival rates for future planting generations. But it would be a fairly boring and short story about the algorithm if it ended here. So just to recap, this is an example from ABP in March 2020 where, as you can see, a number of seedlings were just overlooked and a number of weeds were mistaken for seedlings. Well, we needed to get better, and we did. We trained the algorithm with more than 50 million seedlings and trees so far, and the result is that it was much better at detecting the seedlings when we did a rerun. In September 2020, we had trained the algorithm sufficiently to make a rerun on the ABP data from March, and this is the result. So you can see now that all the seedlings are detected and none of the weeds were mistaken for seedlings in this case. But I wanted to show you some more examples. So far we've only looked at eucalyptus. This is an example in pine where, as you can see, pretty tricky circumstances, a very bright soil, a lot of weeds out there, some soil features, poor contrast. So the algorithm was able to find all these seedlings in there nevertheless. Also, it finds wildlings, and we're able to differentiate them with an additional step of analysis. This is another example in pine, darker soil, less weeds, but very difficult to see the seedlings in there, to find a contrast. Again, the algorithm was able to identify the seedlings and count them all. And this is a further example where a lot of different competing weed species are abundant, and it's hard to even tell which is which. And again, with sufficient training, the algorithm is able to find the seedlings amongst the weeds. So the next time you ask yourself, can you count all the seedlings? The answer's got to be, yes, you can. Well, I said earlier that we're going to look at two examples. So the second one is GTFP, also in the green triangle, where we were first asked to just count the younger generation plantations to assess the survival rate, but quickly GTFP decided to let us count all the trees in 2,800 hectares. Well, we counted 2,694,214 trees, plus or minus 10. But rather than me telling you the story, Wolfgang Drexler from GTFP will join you live after this video is over and tell you some of the lessons learned, the experiences, and the conclusions drawn, and how this helps to improve the silvicultural management at GTFP. So, 50 million seedlings later, we think our algorithm has become really good, and we are very confident in its performance. So that means we can actually provide you with a promise, or a guarantee even, and that our algorithm will find at least 95% of the seedlings in any data set. So that means 95% or more of the seedlings visible in the aerial data will be detected and counted by our algorithm. We also provide a very fast turnaround, so usually we can manage 2 or 3 days, but it will be no more than 5 days turnaround between receiving the original data from you until you get the final maps from us. Once we have established a regular workflow with you, that process will be very quick. And to the cost, the seeding density analysis starts at $3 per hectare. So far, we've only talked about the data analysis, but how do we get the data in the first place? So we analyze data from satellite, from plane, and from drones, but really given the small size of the seedlings, we need high resolution. So usually plane data is possible, but really the best results are achieved by using drones. And really, drones have become so affordable, efficient, and easy to use that they are really the best way of capturing the data. In fact, we recommend the DJI Mavic Pro 2 because it's really small. It folds up. It's so small it almost fits into your pocket. So you fly, or a contractor flies for you, and the data is then simply uploaded to the Skylab cloud, and we take care of the rest. Now, if you decide to fly yourself, which is a feasible business proposition, so you're not left alone. We actually provide you with all of the know-how, the experience. We provide remote training sessions. We give advice on hardware and software, and provide you with all the know-how that you need to get started. And even the mission planning, there's easy apps out there you can do the mission planning with, but we'll help you with that as well. In fact, we can even do the mission planning for you. And then send you the files. You just open them in your own mission planning app like Drone Deploy. And then if needed, you make some changes like drag and change the area or adjust the flight height. And then you connect to the drone, you press fly, and then basically you just sit back, relax, and enjoy the flight. But don't forget to keep your remote control in hand, because in the end, you're still in charge of the flight. Okay, before I let you go, I just wanted to quickly introduce you to some of Little C's brothers and sisters. So we can combine the tree count with height information or 3D analysis and make a full analysis of tree height statistics. We also can analyze the 3D structure of a forest, combine that with some terrestrial sampling to come up with models of the entire volume in a grid-like pattern like this map, or of course carbon storage in this forest. Another example is our fully automated harvest monitoring, where we analyze satellite data to provide you with harvest progress reports and quantifying the harvested area on a weekly or monthly basis. And as I said, we also do some analysis of monitoring change and vitality of forests, seeing how canopy changes, looking at areas of poor vitality or dying trees. And I believe Wolfgang will be able to show you a couple of analysis examples that we did with them as well in his presentation. So, thank you so much for listening. I hope this was useful and interesting for you. It's now around about 4 a.m. in the morning in Germany. It's time to wake up the real me, and I will join you for the Q&A later. If you want to contact me, you just write to me at hello@skylabglobal.com. Or if I don't wake up for the Q&A, that means I've overslept. So please just call this number and wake me up so I can join you in a few moments. All right. With that, thank you very much. Goodbye.